Yeah, hello everyone. My name is Niklas Holtz. I'm in Germany, as you might hear. Yeah, today I'm here to present you my paper. Basically, my paper has the title Multimodal Transformers for Risk Classification, and the subtitle Analyzing the Impact of different data modalities. Before we dive into my paper, I would like to introduce myself a little. After that, we explore the existing literature and take a look at different things. Actually, first, I would like to clarify the term risk. So, what are risks? And then we take a look at different approaches in the literature that also try to classify risk automatically. After that, I would give you a short introduction into multimodal transforms. Building up on this, I would like to show you our approach, which I called multimodal risk transformers. So this is a combination of multimodal transformers and for risk classification. And to do so, I start with a short introduction to our training data set. And then, of course, I will give further information about the method. And finally, I will present you the results. Then another big thing from our paper was the data augmentation or risk data augmentation. I will give you further details when I come to it. And last but not least, I want to conclude a few things and discuss the limitations of our approaches. Okay, short introduction about me. I studied computer science at the University of Oldenburg between 2017 and 2020. During my studies, I got an interest in artificial intelligence. So I decided to continue my studies and do another master's degree from 2020 to 2021. I also focused on the application of transformers. For example, I wrote my thesis about this topic, and after that, I started to work as a software developer. But I found that kind of boring, so I decided to go back to science and applied for a job at Volkswagen. And now I'm a PhD candidate, and that's why I'm here today. And so let's dive into the literature review. What are risks? There are so many definitions of risks out there. I think the most common definition is the triplet of Kaplan and Garrick. It's very common definition. The triplet defines risk as a triplet of event, probability, and impact. But there are also other definitions like possibility of an unfortunate occurrence and potential for realization of unwanted negative consequences of an event. So there are plenty of definitions, and it's hard to say what the right definition is because there are hardly depends on the scope of risk and how you apply risk management, for example, in your company. However, there's a quite interesting definition from Avon. He defined uncertainty as a key concept of risks. And that's actually quite interesting when you think about it, because uncertainty as a non-knowledge about the true value of a consequence leads to the fact that knowledge is plays a crucial role when you think about risks. And therefore, when you try to deal with risks, for example, in your company or something, you have to ask yourself about what are the consequences, what kind of uncertainties are involved, and the most interesting part is what kind of background knowledge exists and how's the quality of that knowledge. So this is just a short introduction into risks. When we talk about risk classification, there are also a lot of approaches in the literature that try to use several techniques to classify risks automatically. And it hardly depends on the field or the area, how well they are actually developed. For example, there's a approach in the financial industry. This is just one example, really. There are so many. They used text classification system to evaluate real world data. There's another approach which tries to export and classify sentences from security reports. And by doing that, they try to kind of use natural language processing to classify those sentences. And it's actually quite close to what I've done, but that's something I'll show you later. And there are also other approaches in medicine, which is also quite interesting because they're trying to combine different data modalities. For example, they try to combine electronic medical records, which might be, for example, notes from a doctor or something, to combine those notes with images. For example, what did I wrote here? Radiological images or other things to classify the risk of a certain patient. So there are a lot of different approaches in the literature and a lot of different techniques. I'm focusing on multimodal transformers as a technique for our approach. Transformers, transformers are a neural network which allows you to automatically turn one sequence into another, basically. You can do it for translating sentences from one language to another, or to process one sentence and then classify it. And that's what we did. One popular transformer would be the BERT transformer, or just BERT, the pre-trained transformer from Google, for example. But multimodal transformers are a little bit more special because they're basically just transformers that allow you to process multiple or different data modalities. For example, text data on the one hand, and on the other hand, image data or different types, for example. But the biggest challenge when you try to apply multimodal transformers for your use case is that you have to think about a suitable architecture, because you can't just combine them because transformers are not built for this. There are basically two approaches to combine this in a kind of another way. One approach would be to have a transformer network inside a bigger network, and then kind of a combining module that just combines the output of a transformer with other data modalities, and this is what you see on the right hand side. Okay, you can see this. I'm sure. So this is better. Okay. So we have a combining module. And this is, by the way, also the architecture that we have used for our approach. After the combining module, other layers can follow. For example, a fully connected layer, which would be the most simple or the simplest way to build such a connection between those data modalities. And another architecture for integrating transformers into such a wide range of data modalities would be to append or actually extend the transformer itself. But this is a more complex task, and I will skip this one here. And okay. Now I would like to talk about a little bit about our approach. First, I would like to give you an idea of our training data set, because we used real-world data. This is a data set that is provided by the risk management department from Volkswagen, and the risks that are considered occurred in the period from 2016 to 2022. And what's a little bit special about those risks is that they can be both internal and external. Internal risks, for example, would be risks that occurred or are related with a certain system, for example, something very special. And external risks would be, for example, the war in Ukraine or something. A total of 5,305 risks are considered, and we have different data modalities here. And as you can see, we have two textual features, which would be a risk title and risk description. For example, a risk title would be supplier insolvency. They can also be much longer, or the description would be the war in Ukraine may lead to the insolvency of the local suppliers. When this is just an example, descriptions can be much longer or shorter. But there are also other data modalities like categorical data. The probability of a risk, for example, is a categorical feature, because we have 5 or 6 different probability classes. And so this is one category. And we have 2 more category features. And then we have 6 numerical features. For example, risk score. The risk score is something that is calculated by the risk management department itself, and they have their formulas, and we try to just consider their scores as well. And last but not least, we have the target class. So this is the class where we want to predict, basically, and we have 6 different classes in the end. And we applied this training data set to 3 different models. We trained them for 10 epochs each, and we trained 3 different models, because the idea is that we then can kind of compare the impact of the different data modalities. At first, we trained the text-only model. The text-only model is a model that as you can guess it, only consists of textual features. So this is the risk description and the risk title. But we also have a title-only model that is trained with the risk title and all non-textual features. So it's basically just without the risk description, and a fully modal math model, which is trained with basically all the data we have. And as you can see, the fully modal model has the highest F1 score. The highest F1 score, or F1 scores, give us an idea of the performance of the model. The fully modal model can predict or predicts 4 out of 5 risks correctly. So I think that's actually quite good. And we can also see that the text-only model also generates a high F1 score, and there's not such a great difference between those 2 models, which means that the categorical and numerical features don't have that huge impact. But there's an impact, and it's this means that the consideration of all data modalities leads to an increase of the accuracy of the model. Okay, this was our approach. Now I would like to show you how we try to augment our risk data. And the approach to do this is actually quite simple. We took our risk reports, we basically iterated through them and tried to extract keywords from the risk titles and descriptions. And yeah, the idea was to, or maybe it should first, we tried to extract keywords with keybird. This is a pre-trained model based on the BERT model from Google. And this allows us to yeah, have like a list of minimal keywords for the title and description. A keyword can either be a single word or a short phrase. So this might be a little bit confusing, but we have also limited the number of keywords to 5. And yeah, what's also worth to mention that we stored the probabilities for those keywords from keybird as well. In the next step, we yeah, created metrics to combine those keywords, because I mean, at this point we just had a list of keywords. The real challenge at this point was to combine them so that we can, yeah, retrieve data that really fits to this risk or matches with this risk. And we have 7 different metrics, and I will show you them in the next slide. But yeah, that's the idea of the metrics. They are just for combining those keywords. And the last step, we retrieve data. We are doing this by the GDAL-doc API. This is an external data source. They store hundreds of thousands news articles, and yeah, we just use them to execute certain search queries to retrieve data for those keywords. And after that, we stored the top 5 articles that matched and to this risk, and yeah, basically aggregated them to our risk reports, and then we train new models. So this is our approach. And there are we designed 7 different metrics, because it's kind of hard to combine them, especially when you deal with internal risks, which are so yeah, so much more detailed than other risks. So we created those 7 for metrics. And for example, I don't want to go into all of these here, but for example, the most accuracy metric is one metric that just selects the keywords with the highest accuracy from keyword, for example. We have another one, for example, the best combined single words is a metric that just combines the best 2 single keywords and then tries to retrieve data. And as you can see on the right-hand side, the different metrics lead to different amount of articles found. So the best combined single words metric, for example, could only find 4,600 articles. And the best single word metric, on the other hand, was able to find more than 330,000. But the number of articles obviously hardly gives any information about the actual quality of the hits. So we thought about a new way of yeah, kind of evaluate the metrics or the articles found. And so we built up or created a quotient to determine the quality of those keywords. And basically, the quotient is a little bit complex to explain, but basically we try to put the accuracy of the keyword in relation to the total number of the hits and trying to retrieve data. And we are also trying to check how many keywords of the descriptions are found in the articles. So the higher the quotient is, the better the quality of the metric is. And as you can see, that the best combined words only found 4,600 articles. This metric also has the highest quality because the quotient is just much higher than the others. And we then tried to train 3 models again with those different data modalities to again compare those modalities, and of course compare the new models to the old ones with the old ones. And each of the model, so there's one new textual feature, as you can imagine, which would be the top 5 news articles. And as you can see, the title only model has experienced the greatest increase in performance. I'm not sure why, actually. I think this is because the title only model wasn't trained with the risk description, and maybe there's therefore a higher impact when you add another textual feature, maybe. But as you can see, the increase is in general more or less quite small. So there's an improvement that's interesting, but it's not that big. That leads me to the conclusion. So we saw that the consideration of different data models. Okay, so we saw that the consideration of different data modalities led to more precise results than the pure consideration of textual features. And we also saw that the multimodal transformer kind of outperformed the normal transformers. And another point is that through the data augmentation, we were able to increase the performance of our models. However, there are quite a lot of mismatch articles that do not fit the given risk and cause a kind of a noise in the data. So this is a problem. And we also saw that it's quite hard to define search queries. That's why we defined so many metrics and evaluated them. This is was a challenge. And also the GDAL API is it's very limited at this point. I'm not sure why they don't offer so many filter options, and also they sometimes they just don't have any data for a certain time period available. So and what was also another problem was that it's hard to find news articles for internal risk, as you can imagine, when you deal with a certain system that's just not known by the public. There are just no articles regarding that. In the future, other APIs could be used to enable more precise searches, because we have seen that the inclusion of other data sources really increase the precision of our model. And the when you would find data sources that cover, for example, internal risks, you could even increase it much more. Okay, thank you very much. Thank you for your attention, and if you have any questions, feel free to ask now.